now move to Hyperledger. And when we talk about Hyperledger, interesting, it is not a blockchain. If we go ahead and talk about, it's more of a distributed ledger framework. So if I go back to the flavors of blockchain, now you would be able to understand why we created this. So if I have to position Hyperledger, I would put it between the second and the third circle, which talks about the distributed ledger technology. However, it also talks about something which is not exactly based on the Merkle tree chain. So when we talk about Hyperledger, we simply go ahead and talk about that it is more. This project was initiated by Linux Foundation. It has various software resources being integrated, and this is a collaborative effort by the member. You have the fabric, which has been generated by IBM. So it's an open source distributed ledger framework which could be used to develop and implement cross-industry blockchain application and system. Now, you have in Hyperledger itself, you have various flavors of Hyperledger. And these are the current ones which I could go ahead and capture and grab it for you all. So you've got a Hyperledger Sawtooth, which is a modular platform for building, deploying, and running distributed ledgers. Hyperledger Burrow is a permissible smart contract machine, permission middle. Then Iroha, it's a business blockchain framework designed to be safely and easily to incorporate into infrastructure projects. And finally, the Hyperledger Fabric, which is very common, has been used by a lot many, is the foundation for developing application or solution with a modular architecture. Now, this ledger allows the component, the consensus, the membership servers to be plug and play. So here are the various consensus algorithm in a Hyperledger. We've already discussed that in a blockchain, and when I say blockchain, I'm talking about a blockchain per se, which is simply talking about the POW as one of the way to go ahead and build that consensus. Here you've got multiple consensus algorithm, and you have the consensus approach. So if I go ahead and look at the consensus algorithm as Kafka, which is there in Hyperledger Fabric ordering service, this is a permission voting base. The leader does the ordering. What are the pros? Well, it provides crash fault tolerance, but what are the cons? It is not Byzantine fault tolerant, so you would always face this issue of the Byzantine issue, which is normally there in the blockchain. Again, these are specific set of issues in blockchain. Are they in scope? Yes, but it would have taken a lot of time to go ahead and further discuss this out. And I really wanted to concentrate on the Internet of Things and the smart contract piece of it. Then you have RBFT in Hyperledger ND. Well, this is something which talks about the pluggable election strategy, which is said to be permission, again voting based. You've got Sumeragi, which is permission, and finally the POET in Hyperledger Sawtooth. So these are the various pros and cons. I would request you all to go through it. Like I said, I would be sharing the slides. This slide does have a lot of content, but I wanted to bring it into your notice because you would get to know the consensus, at least the various form of consensus in Hyperledger itself. So within the sublets of Hyperledger, you see that there are so many other ways of how the consensus has been built to form a blockchain network or a distributed ledger network, if I speak it in a proper. So the standard proof of work, as we talk about, and we compare it with the blockchain of the Bitcoin part of it, you see that there are three ways you can go ahead and compare it. One is permission lottery based. The second is permission voting based. So if I go back, you can see Hyperledger Fabric, Hyperledger ND, as well as the Iroha. These all are basically the first two are the voting based. So if I go ahead and look at it, you're going to find out that the speed is far, far better in a permission lottery base. It is very good. In a voting base, it's again good. But when it comes to standard proof of work for a Bitcoin, it is slow. And that would also go ahead and help you understand when we talk about the most famous implementation of blockchain, which is Bitcoin, as to why it takes so much of resources, it takes so much of time to generate a Bitcoin. And because the very consensus building doesn't happen, or the proof of work doesn't happen in the permissioned lottery based or a voting based system, it is an entirely different combination of hashing algorithm generating that kind of hash that leading zeros, which could go ahead and help you into getting added as a node. Second is scalability. In the lottery-based system, again, it is good. In the voting-based system, it is moderate. When it comes upon the standard Bitcoin, the scalability is again good. Finally, lottery-based, moderate, voting-based, it is good. And from a standard, again, proof of work, it is poor.